Hey guys, welcome to Module 47. Today we're talking about photochemical smog and acid rain. So there are two different types of smogs out there. We have the industrial fog that we find in cities like London, and it's composed basically of smoke and fog and sulfuric oxides or sulfur oxides. The Los Angeles brown photochemical smog is kind of the grosser, it's the stew of secondary pollutants that we were talking about before. It involves volatile organic compounds and transformations due to the sunlight. So let's understand this a little bit more. The first part of photochemical smog is going to be the interaction of nitrogen oxides with sunlight. And so what happens in the morning, we have nitrogen dioxide is going to break down due to the energy of the sun. It's going to break down. Remember we said that nitrogen monoxide is going to turn into nitrogen dioxide, or it's going to, that bond is not very stable, so it's going to sort of transfer back and forth pretty readily. So in the mornings, the light energy from the sun is going to break this molecule down into nitrogen monoxide and oxygen, or one single oxygen molecule. And so because we have one single oxygen molecule here, it's going to interact with the diatomic oxygen that's in our atmosphere, just naturally occurring, the oxygen that we breathe. And so O2 plus O is going to give us O3. And so that's going to be how we build up ozone in the atmosphere close to Earth. And so this is going to happen every morning, but as the sunlight goes away, we're going to revert back to this O3 is going to release that oxygen, and that oxygen is then going to attach back onto the nitrogen monoxide. And so we kind of start off in the same spot that we were before. We have diatomic oxygen and nitrogen dioxide. And so we have the formation or the construction of ozone and then the destruction of ozone in the evenings. And so this is all well and good. Ozone doesn't build up unless we introduce VOCs, or volatile organic compounds. Remember that these are the result of things that evaporate pretty readily. So like spilling gasoline on the ground. And remember that they also occur naturally. So if you have an area of a forested area with lots of pine trees, that pine smell, that's also a VOC. And so what happens here is the first part of the construction of ozone occurs. So we have nitrogen dioxide, sunlight's going to hit it, it's going to break down, and the oxygen is going to attach to diatomic oxygen, and we have ozone. But when we introduce VOCs, what happens is that it is going to interact with this nitrogen monoxide, and they're going to form stable bonds. And so the nitrogen monoxide is not going to go back to, it's not going to be able to re-accept this oxygen. And so the ozone is not going to be able to break down. So what happens is, because we have the introduction of these VOCs, this ozone builds and builds and builds. And so we don't have that sort of, that build up and break down, and it accumulates and now becomes problematic. Another variable in smog is temperature. So as you increase the temperature, a few things happen. You're going to obviously evaporate more VOCs. So there's more, because there's more sunlight, there's more energy. It's going to increase the amount of chemicals that are going to evaporate and interact with this smog. Also, when it's warm out, people are going to use their air conditioners. This is going to create more combustion because we need to give people the energy or the electricity to run their air conditioners. So we increase the amount of NOx into the atmosphere. And finally, just because warm air increases the rate at which gas moves, you're just going to increase the rate at which these secondary pollutants in smog are going to occur. The last way that we're going to talk about how temperature influences smog is by thermal inversions. A thermal inversion is a layer of warm air sort of trapped mid-altitude between two cooler layers. So if we have a warm layer here, the cold air on top, so if you have your warm layer here, the cold air on top is going to trap it right there. And so you trap, so this warm air can't move, can't go up. And so what happens is everything below it is going to be trapped down there. So this is a thermal inversion, because usually you have your warm air down below, and as you move away from the earth, it gets cooler and cooler. And so therefore your pollutants can escape into the atmosphere and be less problematic, where we're not breathing them in, causing respiratory problems and influencing our tissue. But what happens is when we trap all that pollution down below, it's going to have a greater effect, and it's going to increase the amount of smog that we're dealing with. All right, let's talk about acid rain. Acid rain or acid deposition is going to occur simply because there's carbon dioxide naturally in the atmosphere. And so you're going to have carbonic acid. And so that is going to reduce the precipitation that we have from 7, because water is neutral, down to 5.6. And so anything below 5.6 is considered acid rain. When we introduce the NOx and SOx into the atmosphere, this is going to be when we start to see our acid deposition or our acid rain, because it's going to produce, let's see, I feel like I've hidden it, there it is, because we're going to start to produce nitric acid. So the interaction of the nitrogen with water, we have HNO3, nitric acid. And when we introduce sulfur in water, we have H2SO4, sulfuric acid. And so what happens is nitric acid and sulfuric acid are going to break down further. So when they're on the earth, they're going to create nitrates and sulfates, and that's going to impact our water. So what happens when we add more nitrogen or sulfur into our water? We have problems, because we're going to increase the amount of nutrients, causing eutrophication. But then we also release hydrogen ions, causing the entire environment to be acidic, because we know that the addition of hydrogen ions in water or in an environment is going to increase the acidity. And so the transformation takes a few days, and the pollution can travel over 1,000 kilometers or 600 miles. And so how is this going to affect the ecosystem? It's going to negatively impact vegetation. It's going to negatively impact soil, things that are living in the soil. It's going to enter into the water. It's going to change the pH of the water. We also have dry deposition. So we can have gases in the air being acidic and having acidic particles, which is going to impact our respiratory system as well. So acid deposition in the U.S. has been greatly reduced since 1990. Actually, in the White Mountains, they have seen a big change over the last 20 years or so because of the Clean Air Act. The water at one point was unlivable for many species because the water was becoming too acidic. So if you remember this range of tolerance, a lot of species, amphibians, will survive in a lake 6.5. So this is where they are going to survive. And here is our zone of physiological stress. So this is about 6.0 to 5.5. And this is when our organisms are undergoing reproductive problems. They can maybe be there. The strong ones can survive there, but they can't reproduce. They can't live a full life. And so very few are going to be able to survive there. But in the White Mountains, our lakes and ponds had actually gone out of that zone of physiological stress and were at the zone of intolerance. And if you can picture the United States in the White Mountains, you have the westerlies blowing all of the air pollution across the United States over to the White Mountains, and then also up north along the East Coast. And so they call it the exhaust pipe of the United States. And so the air pollution in the White Mountains was pretty bad, and so the acid deposition was pretty bad as well. But they're finding that the amphibians are now coming back into this area of tolerance, and the numbers are starting to increase. So that's good news. So we can implement regulation and create change. And so that was a direct effect of acid deposition. An indirect effect of acid deposition is the mobilization of metals, or heavy metals specifically. So remember that on our soil particles, we have ions, and they can be heavy metal ions like aluminum, like mercury, like lead. And so when we introduce acid into soil, it's going to immobilize, it's going to remove these little heavy metal particles, and it's going to put them into the soil where we can take them up and we can consume them. They can, or animals or plants can take them in. And so heavy metals can impair cognitive function and cause loss of biodiversity. If you remember, lead was really bad. It just impacts everything negatively. So we definitely don't want that in our soil and in our food. Finally, to keep in mind, acid rain isn't going to hurt our skin if it falls on our skin. It's not that acidic. But it also can impact human-made structures. So if we think about the Acropolis, which is about 2,000 years old, it is now starting to erode because of the acid deposition. And so there's a sense of a need to preserve these structures that are very meaningful to us, but there's really no way to protect them. So that is it for today. I hope you have a great day.